Hello, this is a video on how to compute the probabilities of a Poisson process in Excel. So our problem is dealing with a McDonald's manager that knows that cars arrive through a drive-through at an average rate of 2 cars per minute. So you get 2 cars for 1 minute of time. This is between the hours of 12 noon and 1 p.m. And they're asking us to determine that exactly 6 cars come in a 5-minute interval, that fewer than 6 cars arrive in a 5-minute interval, and at least 6 cars arrive in a 5-minute interval. So if you remember from lecture, you need the mean to calculate each of these probabilities in Excel. So at the next slide, we'll see that we need the mean to compute the probability in Excel. So if we get 2 cars every minute, and we care about a 5-minute interval, it seems reasonable that we would get 2 cars, or there's 10 cars for that 5-minute interval. So this is the math that's being done right here. It's lambda, which is 2, times time, which is the 5 minutes, and it gives us 10 cars. But remember, if we just look at the problem, we don't have to worry about these variables, lambda and time. If I expect 2 cars every 1 minute, and I'm looking at a 5-minute interval, then over those 5 minutes, I should expect 10 cars. Okay, so let's go over how to do that math in Excel. So if you remember from the last slide, we need exactly 6 cars. So in Excel, zoom in, and I need the Poisson distribution, P-O-I, and there it is. Once it's highlighted in blue, I can hit the tab key on my keyboard, tab up on the left-hand side, and it fills out the distribution for me. Now I can see the prompt is asking me for an x, a mean, and then whether or not the distribution is supposed to be cumulative. Do I care about this version of x, or do I care about everything that happened before x? So in the problem, it's asking me about exactly 6 cars. So right now I care about exactly 6 cars. So 6 is the number of cars, which is the variable x. The mean, we just said, since it's 5 minutes, should be 10 cars for 5 minutes. And then cumulative, we care about exactly 6, so I'm going to say false to cumulative. Okay, so this is our solution for part A. So the probability of exactly 6 cars arriving between 12 noon and 12:05 is about 0.63, and I believe your book rounds that to 0.0631. Okay, so this is exactly 6 cars. The next part of the problem asks us for fewer than 6 cars. So fewer than 6 cars means 0 through 5, because we don't want 6 cars. We want strictly fewer than 6 cars. So I have a couple ways I can do this. I can calculate the probability that exactly 0 cars arrive, that exactly 1 car arrives, that exactly 2 cars arrive, that exactly 3 cars arrive, that exactly 4 cars arrive, and that exactly 5 cars arrive. So this is exactly x cars, where x is the number below. Then I would figure out the probability for each one, probability. So down here, that would be the Poisson distribution. I would care about this number next to me. The mean is still 10 because it's still over that 5-minute interval. And since I care about exactly, it would be false. Again, to cumulative. I can spell false. Oh, that's E. There we go. Little tiny probability. I'm going to click and drag that down, and I will get the probability for each one. And then at the bottom, I can sum them up. I would sum instead of multiply because I need ors here. I can get 0 cars, or I could get 2 cars, or 1 car, or I could get 2 cars, or I could get 3 cars, or I could get 4 cars, or I could get 5 cars. And then all of these possibilities would be everything fewer than 6. So this is one way to get the probability, and you can see it works, but it might be really time consuming if it was like fewer than 12 cars or fewer than 15 cars. So there's another way to do it, and that is to use the cumulative. So this is fewer than 6 cars. So that's what I'm going to try and calculate. To get there, I'm going to use cumulative, and cumulative talks about 6 cars or less. So over here I'm going to say 6 cars or less. That's the only thing cumulative will give me. So I'm going to say the Poisson distribution, so equals. My keyboard stopped working. Hold on. Okay, I think I'm working again. So equals Poisson distribution, and I care about 6 cars, and the mean is still 10. And now I'm going to say that cumulative is true. Cumulative will give me 6 cars and less, so it'll include 6 cars. And remember, I don't want to include 6 cars. So the way to go around it would be to subtract out the exactly 6 cars. So this is equal to this number minus 6 cars. You see I get the same number. So remember the cumulative is finding 6, 5, 4, 3, 2, 1, and 0. And so I just subtracted out 6 so that I could get 5, 4, 3, 2, 1, and 0. So it's just another way to be able to do that math. I'll show you that equation one more time. So I calculated it with cumulative true, and then here I subtracted out the 6 cars exactly. So either way, the probability that fewer than 6 cars arrive is 0.067, and your book would round that to 0.0671. Okay, so going back to the problem, we have part C is at least 6 cars arrive between 12 noon and 12:05. So at least 6 means 6 or 7 or 8 or 9 or 10. And with the Poisson distribution, there's no limit. So I have no idea where I should stop calculating this. So it could be 6, 7, 8, 9, 10, 11, 12. I have no idea when I should stop. Because of that, I'm going to use the property of complements to figure this out. So I know exactly 6 cars, and I know fewer than 6 cars, and now I care about at least 6 cars, which means 6 or more. Okay, so if this is fewer than 6 cars, and I need 6 or more, then I can use my complements, 1 minus this, fewer than 6. Okay, the opposite of fewer than 6 is 6 or more. So I just do that subtraction, and now I have my 3 solutions. I'm going to insert a column here. I'm going to delete that column, insert a column here, and I can name these. This is A, this is B, and this is C. Move that over there. And now we have our solutions. So this is A solution. Make that a pretty color. But you can still read. So a light pretty color. There we go. And this one is a different pretty color. And this one is an even differenter pretty color. All right, so to find exactly, we used the Poisson distribution without cumulative. To find fewer than, we used the Poisson distribution with cumulative and subtracted out the 6 cars, the exactly 6. And to find at least 6, we just did a complement move. We did 1 minus fewer than 6 to find at least 6. Okay, and that would be how to compute the probabilities of a Poisson process.